Okay, so ladies and gentlemen, we're going to get going here. It's great to see people again, and we're going to have a very full day that's going to be consisting of much hands-on coverage, as well as much coverage associated with some conceptual material that will very likely be new to everyone in this room, actually. So to get started, I'll conduct a bit of a retrospective on what we saw yesterday. Yesterday had included many different components. We hit on a lot of hands-on practical material yesterday. Notably including adding of aspects of environmental structure in the form of networks to the model. We specifically built in a network between individuals that served as a conduit for sort of a stylized representation of influence or norm-based influence from neighbors to those with a behavior, with a smoking-related behavior, and we use that to impact initiation. We also modified the model so that we had a additional set of components that ended up affecting initiation related to intergenerational factors. So we actually passed on early on, we assigned each person in the model a socioeconomic status, and that was inherited by a child within a family. So if a mother gave birth to a child, that child carried the socioeconomic status. That took place at, as you might expect, at the point of delivery, where the mother's, that is the mother's socioeconomic status was used to dictate the socioeconomic status of the child. We then went on and extended that to reflect a situation where we had influence as to whether the mother was a smoker at the time of the delivery, that influencing the child in the form of exposure to smoking. And that led to a interesting case study in a point that I had made a day or two earlier with respect to these types of models. When building these models, we try to do so incrementally with one of the major motivations. There's many motivations for that. Always have something in hand. You learn from the model and could choose the next step more effectively. And there's often a much greater clarity on how long the next step is going to take if it's a small step. But beyond those and other benefits, one of the benefits for adding pieces in small bit at a time is that if there's a bug introduced, you can more easily crack it down because there's fewer things changing. If there's new behaviors elicited, you can often zero in more quickly on what was causing that behavior because you only made a few changes. And yesterday we saw concerns about both of those latter two things, that there was behavior that was unusual. We had a very large fraction of the population becoming smokers. And secondly, there was a thought that it might be due to a bug. And this brings, again, to this point that I had made a day or two earlier, which basically said that it's not easy in these models sometimes to distinguish a defect in the model and the model implementation, a problem with how you've implemented the model, to distinguish that easily from an emergent behavior. Both are surprising. both might make you think, okay, what's going on here? And yesterday we saw exactly that. Through a confluence of insufficiently careful display of the data from the model, the fact that we were displaying data in that pie chart, those pie charts relate to the whole population, not just the adult population, those subject to smoking risk, on the one hand. And because there were contagion effects, what seemed to me likely to be a bug was in fact an emergent property of the model. It was a behavior of the model that came out of a confluence of factors that I hadn't anticipated, and that actually made testing that, whether or not it was a bug or not, more difficult, because I had in mind a mental model that we should see a big difference between a population that was exposed in utero and not, and the difference was a lot less because there were contagion effects. So the higher risk among those in utero ended up rippling through to higher risk of smoking among those not exposed in utero due to contagion effects. But and that took us down a bit of a distraction, but hopefully it illuminated concern in vivid detail about how you could have these mistakes or these confusions that on the one hand could be a bug, on the other hand they relate to phenomena that could be an emergent property. But more to the point, it also, or also equally importantly, it also highlighted the fact that we had, Winchell, maybe you could help with something here. That we also had a way of actually probing these things, which was very powerful. Maybe you could see if you could get the smartboard on here. That was very powerful, a very powerful means of probing what was causing things. Specifically, we were able to enable and disable things. Enable and disable the phenomena that might be driving it through different scenarios. And you'll notice how I did that. I went down and within the model, we have a set of scenarios which allow us to probe different possibilities. Possibilities which do include contagion, those which rule out contagion. Those include intergenerational influence, those without intergenerational influence. It could allow us to turn off essentially the effects of network, effects of, if we wanted to, we could put one in place for socioeconomic status, turn effects of that off. And by running a model with these different controlled experiments, we could often arrive more quickly at an understanding about what might be driving behaviors we see in the model. So that's a very powerful thing that we can't readily do in the world, unfortunately, turn on and off influences of certain causal pathways. We don't have the luxury of doing that, but we do in a model. And that affords us a clarity of thinking that we can develop because we understand the unique contributions of each of different pathways by being able to experiment with them. Enable them, disable them. So that was an important component of my investigation. Another component of my investigation, of course, was going into the model and disabling things within the model itself. And to do that, I make a separate copy of the model so I don't mess anything up, and then I can adjust that as I see fit and investigate and then pop back to the original model once I've secured some understanding. But it's much more versatile. It's much less cumbersome. And I would opine more, it's much less risky in terms of making a mistake that I forget and forgetting to correct something back. If I conduct experiments through these different scenarios, which any logic calls, appropriately enough, experiments. These experiments don't lead me to modify the model. In other words, when I run an experiment, it's running the model with different assumptions, but it's doing so in a way that doesn't yield any persistent change to the model. So I can go run one experiment 1 minute, another experiment the other minute, with very different assumptions in a very fluid way without having to go change something in the model. If I change something in the midst of the model, I can achieve that same goals. But the problem is that I may forget to change it back. I may get a phone call, in the middle of the experimentation when I've made a change and I'm experimenting with it. I get a phone call, I'm distracted, I get a lunch. By the time I come back, I'll go teach. By the end of the day, I've forgotten that I've changed something in the model, and it's got some non-standard assumption there. And then I keep on using it as if it's the baseline model, as if it's the reference model, when really inadvertently it has some mistake. It has a mistake that I meant to flip back to its original value, but I neglected to do so. Very practical issue, and one we can avoid in large part, perhaps not always, but in large part, through using different scenarios. Scenarios which tell the model to assume something very clear, and but do so through this mechanism of parameters. Now today, likely by the end of the day, we will see a mechanism by which we can specify within scenarios even things like targeted interventions that target certain subgroups within the population. And they're far from having to go and hard code that information in the model itself in a way that would then need to be undone for another targeted population. We can actually specify which intervention we wish to undertake and on which groups we wish to undertake it within the experiments, within these scenarios. Okay? So scenarios are important. They afford you a way of experimenting with the model. And this is an area that any logic I think it's fair to say that Jeff and I helped really push this this realization on any logic's part, just how important these are and how important sharing results from scenarios is to the scientific process. Being able to have a persistent record of what you found when you ran one scenario to another. Traditionally, we have a lab notebook where we write these things down, or we'll have a OneNote or EndNote or OneNote or other online service that will allow you to take these things down, etc., and take notes on it. Any logic is investing in a significant way in having shareable scenarios that I can share information with you. For example, you could easily see the results of what I've run with these scenarios, and we could share it online in a collaborative way, which is a powerful construct. An important point here, though, that I want to make conceptually about scenarios, they're really both minute to minute important, but they're important in a conceptual way. But one thing to realize is that if you pair up a scenario with a given model in the same random number seed, you should get reproducible results. The exception being any external data sources that it may draw on, something we'll also talk about today, drawing data in from data sources. As long as those are all the same, you should get reproducible results. Results you could run again. You get back a paper review for one of your papers, asking for changes. You want to be able to reproduce your earlier runs with precision and make requisite changes to them. You don't want to be wondering which scenario was it, which version of the model, which version of the parameters were I using. And along those lines, there's an existing weak link in this that you have to be cautious about. Ladies and gentlemen, when you run a scenario with a particular model, random number seed, same data sources, you get the same result. If your model changes, if I were to go add a transition in this model that somehow changed this, we added e-cigarette use or something like that to this model, that same scenario, same random number seeds, same external data sources would now give different results because it's a different version of the model. The model structure is different. The model logic would be different. Now it is e-cigarettes competing with cigarettes or what have you. So remember that these scenarios don't automatically only exist with respect to one version of the model. They actually, their results will evolve with the model. And as such, it behooves you to save away successive versions of the model. Save away versions of the model that you did use for that paper that you submitted so that you know exactly what version of the model, what scenario you did, so you can go back and reproduce it precisely. Because if you submit that paper and 6 months hence you get back a positive review, but they want some changes, you don't want the model to have advanced by leaps and bounds until then and be unable to recover what was used for that, what was the version of the model used for that paper. So you'll notice that I am saving away successive versions. We're up to version 14. One model I have, I think our GDM model, original GDM model, we're up to version 264, I think. And the point is that by saving away those versions and by taking notes, good notes in a structured form about which versions of the model we're using for certain experiments and the results, that lends itself to a reproducible scientific investigation. Along those lines, AnyLogic does provide, up here, if you go to File, excuse me, I guess it's not in the PLE version. Okay, oh, sorry, there it is, SVN. Probably for most people in the room, you won't be familiar with this. There's a system very, very widely used in software development that's called Subversion. It is one of two major systems. Git and Subversion are sort of the dominant way of maintaining what we call source code, the information out of which we build the sort of descriptions, the so-called code that we use to build programs. Lots of other Subversion systems also store other information like database schemas or structure information, etc. And with Subversion, you can save away successive versions of your model transparently without the need to litter your computer with version 1, version 2, version 3. You'll have them at your beck and call at any time just by checking them into the system. It maintains a complete history, lets you easily compare two different versions of the software, lets you easily go back and retrieve them, and lets you share them with people from around the world. Now, I'm not trying to sell people on this, but if you have someone that you could talk to about how you use so-called version control systems like Subversion or like Git, you might find it a very, very convenient way of storing models, and AnyLogic does provide direct support for Subversion. I'm hopeful that maybe Git support will be coming soon enough from St. Petersburg. But that's a link here to information, to ways to store history of a model. AnyLogic is aware, and this again goes back to some work I did, 7 years ago now, 8 years ago, in building systems that have built-in connection between scenarios and models and can store the results of a scenario when applied to a certain model with a certain random number seed, and as the model evolves, still allows you to go back and easily get those earlier results or to run that scenario with the new version of the model. These are things which AnyLogic greeted with some interest. And my understanding is that they are trying to formalize that process so that you can more easily experiment with different versions of the model with your scenarios, et cetera, share that information. So they're working towards a scenario manager. And Jeff or Winchell might have encountered more detail on this than I. But I understand that it's a significant part of their plans. Is that in version 8? Do you know, Jeff?
Yeah, I mean, it's kind of due about now.
Yeah.
But they've also added the cloud to 8, so that may
Sorry?
They've added the cloud to 8.2.
Exactly.
May slow it down.
So that we can run scenarios, not just on our computer, but on large numbers of machines out there.
And that's one of the main reasons they put the database
Exactly.
version 7 is to get this much more flexible scenario version.
Scenario management, et cetera, which is really for us as investigators very important. Maintaining records of our investigations, et cetera. Yesterday, well, I'll come to that in just a minute. We'll come back to this cloud issue. You'll notice someone also asked me yesterday, is there a way in my investigations, gosh, if this was possibly a bug, is there a way that I could, instead of pointing and clicking through here and saying, is this right, and trying to go and look at how I've defined this hazard rate or what have you, is there a way to get a summary of what's in the model? And the good news is there is. So if you go to Tools and you see Create Documentation, this provides you with a way of creating documentation on a model in one of several different forms, as a Word document, as a PDF, or as an HTML document, HTML page, and using that information to have some information about what's in the model. Now, when you do this creation of documentation, you can say finish immediately to generate a more default set of information, but you can also go to next and you can select what sort of types of information do you want to include about the model and from what sub areas of the model. So for example, maybe I'm just not very interested in including information on my presentation and my controls that I have to sort of interact with the model. Maybe what I'm more interested in is some things related to the analysis data, general features of the model, state charts of the model, and charts. And perhaps I don't want to have all the information on the different scenarios, but just the core parts of the model. I could then check and uncheck these boxes. So maybe just to follow that, I don't want information here on the controls or presentation, and I want to get rid of information on these things here. I'm just going down and doing space. And I'm going to say finish here, and it will actually prepare for me a document that includes a description of the model with respect to these features. Okay, and here it is. Here's my PDF. So here's information on various parameters. For example, you'll find some information on events. This is this event to populate a histogram, for example. And further down, we'll find information, for example, on the state charts right here. Okay, there's our initiation hazard information. Okay, generating this documentation can be quite valuable. It can also be valuable in terms of helping us sort of get us understanding of what's in the model. Now, Winchell, take a look at the bottom of what's at each page there. Yeah, there's some. This it's not clear why this is. It's saying 24 null 28. I think it's 24 out of 28, but the meaning of it is imprecise. Okay. Anyway, generating documentation is a useful feature of the software. It allows you to get a model description, and you can do so in an editable form such as Word or HTML, if you were so inclined. Okay. It's another feature yesterday. Now, yesterday's, the latter part of yesterday, in addition to adding these features and tracking down bugs in my thinking that I thought originally were bugs in the software, in the model, after that, we went into a very important area of discussion, which concerned sensitivity analysis, as captured in parameter variation experiments. And we looked that a model's output could actually vary in some notable ways due to stochastics alone. Due to stochastics associated with the characteristics of the initial population, with the timing of transitions, with the vagaries of who was connected to whom in a network, etc. There's actually quite a bit of variability in the output that is possible. And we saw that we could summarize this variability. We could examine this variability through use of a parameter variation experiment. Okay? And parameter variation experiments provide us a way of doing one of two things. Either number one, conducting an experiment where we keep all parameters constant and we're simply modifying we're simply having stochastics vary. The realization varies in terms of the stochastics, the realizations of the stochastics. We could investigate that, or we could modify the values of parameters. So here's a case where we are running 10 runs. Generally, you want quite a few more than that. And we have fixed values of parameters, and we were looking at what came out of that. And a very important point here was that you want to conduct those sort of experiments with random seeds, so seeds that vary from run to run. So we have different stochastics, not the same stochastic. And secondly, this is an experiment type that runs the model many times. Main, which describes sort of the overall world, will run from start to finish many times, in this case 10 during this particular experiment. And each time it runs, we will rescue some information from it. We will salvage some information from it, and we will display it within our experiment. The experiment outlives, in short, main by far. While the experiment lives, it'll run main many times. Okay? This was a pattern that held for both stochastics and for the case where the parameters were in fact varying. We saw two ways to summarize this that are popular here. One way is with a histogram, where for each run we added some information to the histogram. The other way is with a histogram 2D object, which provides us a way of summarizing behavior over time across many realizations by creating a two-dimensional histogram. So we have bins conceptually, binning going on along the x-axis for time, the y-axis for values, and a given grid square indicates the number of trajectories from any of the realizations that have fallen through that grid square. And that grid square is incremented. The contents of that grid square, starting at 0, goes to 1, 2, 3, for each successive trajectory that goes through there. That's sampled at the appropriate times, and it's increased. And this provides us a way of summarizing across many, many runs the values that are obtained. We saw that beyond doing this for stochastics, we could further do it, ladies and gentlemen, for when in fact varying parameters. So here, yes, there is stochastic variability going on. We could handle that with replications, if we wish to do so. Have each, for each iteration, for each value of the parameters, any given combination of values for the parameters, we run the model a certain number of times. Here we ran the model parameters certain parameters, we ran them systematically, stepping through a set of different values. Okay. If you're not interested in arithmetic steps where we increase it successively by a fixed value, and you want to have multiplicative, more successfully larger multiples, you could do that. You would just have a parameter essentially representing the log of that, which would increase arithmetically. So you'd have I increase from 0 to 10, and you'd be examining, I'll be with you just a sec, Jerome, and you'd be examining a parameter that's 2 to the I times some baseline value. Yeah, Jerome.
So why do you run the parametric variation with relative C?
That's a good question. Generally, it's because we do seek to have some use of replications. And with replications, what that means is for a given assignment of parameters, as we say, parameter vector, this parameter A has value X, parameter B has value Y. For that, you'll run it maybe 10 times. Now, if you don't do that, you could do it with a fixed seed, which would have the benefit of being reproducible, but it would not be in any way a kind of, it's not like that fixed seed is in any way privileged. It's just one particular realization for that combination of values, A being X, B being Y. And it's not privileged, but it would be reproducible then, which might, so if you're not going to run replications, doing it with a fixed seed is probably a reasonable thing to do, because then it's reproducible completely with the same model as long as the same data is used. Okay? Good questions. Other question I could answer about this. I'll make a few other remarks on this. No other questions? Yeah? Okay. So you notice we could do this variation in parameter values on a one-by-one basis or on a multi-way basis. We could conduct it in a fixed way or in a Monte Carlo way, where we actually draw values for distributions for each parameter. Generally speaking, you will often conduct these sort of parameter variation experiments with an attempt to compare apples with apples by adjusting parameters within some defined range, proportionally speaking, for their values. So going from something like 10% less to 10% more, or 1% less to 1% more, to allow you to sense the sensitivity or the elasticity of the results. Sensitivity being a question of how much does the output vary over a 10% change in the input. How much does the output vary in terms of excuse me, I should be careful with that. Sensitivity would be what is the numeric value, the range of the numeric value of the output over the numeric range of the value of the parameter. By contrast, we can compute elasticity. What's the percentage change in the output versus the percentage change in the parameter value? So we'll often do that. We'll often conduct it in very fixed ways. So here I use that strategy. I varied this parameter from 10% less to 10% more of its value, and the same thing with this one to sense the relative change in the output. And we saw that it was different. We saw that for the contagion, it was approximately 3 times broader a range that was elicited in the output. The output of being the fractional prevalence here. And that was interesting. We then ran a multi-way sensitivity, a 2-way. Left by itself, we only did one of these. It's 11 possible values. Since we did all combinations, this is a gridded combination of values, we had 11 times 11, or 121 possible values. And when you folks departed the room, perhaps with an elevated heart, I was running this yet, and I stayed here. I think we were here for another hour and a half, perhaps, to finish the run. Not quite while you slept, but at least on your way home. So this is, I promised you the results. And while I doubt you've been waiting in enormous suspense, perhaps you have some interest here. So I'll, if it's okay with you, I'll show you these. So here, ladies and gentlemen, are the results from the 120 run. And I show this for two reasons. One reason is it's kind of interesting to see the differential patterns for each in isolation versus together. Here we had a real sort of notable distribution. Secondly, because we were running 121 runs, a larger number of runs, we get a better sense for that distribution. It's better sampled. And here's the 2D histogram, where again, time runs along the x-axis, value fraction of the population that's infected along the, or excuse me, that's smoker, current smoking along the y-axis, and you'll see a certain regularity with this, and you'll see this kind of band of somewhat darker concentrated values, but then also a sort of slow uptake. What this run also suggests is that 100 time units is probably not enough to capture a lot of the dynamics, because we see this real transient forming. Well, I shouldn't say transient, it's a real pronounced dynamics towards the end of this, with some of the runs not even completing their rise. And there'll be a lot of interest on my part as to what you see after this. This suggests that maybe we just got through the burn-in, we're getting through the burn-in period, and it was transitioning to a new regime where there was something going on interesting, and we cut it off at 100. That's something that you want to have your eye out for. Yes, Anton.
I have two questions.
Sure.
Back to one of them. My first one was how much of that would you? I was looking at when you say, oh, well, that's burning. We should chuck out the first, I don't know, 40 times areas or 50. Would that be?
Well, I'd be very cautious about saying that right now. The real question in my mind is, okay, so this is unexpected to me. I did not anticipate seeing this. I think that's worth investigating. I would go and conduct a set of controlled experiments. My first hypothesis, so remember, when we're running with these models, we should have hypotheses in mind to help us at several levels. One is a hypothesis to shape what we're picking to go into the model. Another hypothesis is when we see something unusual, we'll develop a hypothesis for what might be driving that and then investigate it. And so it's not a privileged hypothesis, it's a working hypothesis. We'll try it, put enough effort into it to give it a fair go in terms of scrutinizing whether it makes sense, whether we could falsify it. Here, my guess is that is due to, in significant part, to contagion effects, leading to a large fraction of the population to become smokers. How long this goes on, how high it goes is, I think, an interesting question. Why it took so long to capture that transition. This is after 100 years, where we have pretty strong contagion effects operating within an individual over time, I think is an interesting question. So I would try a set of controlled experiments to test this. I would run the model out with significantly longer time frames to see if there's some sort of phenomena beyond this, where it's not going to a new steady state. It's not going to a steady state regime where it's more or less imbalanced, but maybe where it's in constant disequilibrium. Maybe there's a cycle, or maybe there's there's an ongoing kind of exploration around some area that's hard to predict, and it causes big time frames, big changes. But it is true that that it's possible that this is a burn-in period and that this earlier stasis is not something we would see again, but it's rather an artifact of the initial state of the model. The fact that we, per Jerome's question and insight, we didn't in fact put people, distribute people as we would seek to in another model. We didn't distribute them initially with respect to their cumulative time spent smoking, for example. So we have these people born full-blown like Athena into the world from the head of Zeus, lacking a history of smoking. They might be a current smoker now, but their lungs were of the beauty of the snow, Saskatchewan, in terms of pure whiteness. So in fact, it is possible this is due to an initial transient, but I need to experiment more to sort of test that hypothesis.
Could you not, we could set this up such that it keeps track of what caused that person to begin smoking?
Yes, we could.
Started on this run of smoking.
Yeah.
Due to social contagion, this person was.
Well, okay. This is a very interesting question. We will soon enough see a way. Before this day is out, we will see a way of doing something like that for certain types of causes. But as has oft been the topic of discussion between the sage of the bearded sage of Sydney in yonder corner and myself, we have to be cautious about introducing sort of a notion of event-driven causality, where this particular trigger caused this outcome. For many circumstances, we have to be cautious. And I would particularly highlight the fact that right now we have within this model, if you go and you look, there will be times where we'll have things triggered by very specific causes, and we could attribute things in a clear way. But right now we have initiation, for example, that is driven by a confluence of different factors, right? There's a higher chance because of my in utero exposure. There's a higher chance because of the number of individuals around me who are currently smokers. There's a higher chance because of my SES. And as far as trying to apportion, for a given individual, why did they become a smoker when these are tangled together, it would be very challenging in my mind to say this person became a smoker because of their buddy, because there's other factors contributing to this. And it'll be hard to say, well, was it because, they also had a mom who smoked, and so they had a higher propensity there, and they were from a poor neighborhood, and so there was somewhat of a higher propensity, perhaps because of that, because implicitly because of availability of tobacco outlets or what have you. The point is trying to apportion that here would be I don't know a way to reliably do that. Yeah.
Can't we actually access all those data points on a unit time?
Yeah.
Once that event's triggered, you'll be able to capture each of those
Components. Oh yeah. Oh, absolutely. Absolutely. It's just trying to say it was uniquely due to this buddy compared to that buddy. It was Joe who offered me the cigs, and got me smoking. That would be a hard thing to do. And because Joe and Sam and even Steve might have been, neighboring smokers who influenced me equally.
But you could, for example, put in a bit of code there which actually save that to a database.
Absolutely.
So which basically you get like a graph of.
That's right.
Yeah.
So keeping track that this person who did initiate smoking, that that was a person who had in utero exposure to cigarettes. They were from this strata of socioeconomic status. They were this age, and they had, 4 connections who were smokers among their 10 connections overall. And one of them, Donald, was the worst. Well, okay. Anyway.
Let's not.
Yeah. That's who it is. Okay, other questions?
Yeah, a purely pragmatic question. I
Yeah.
can see that, we could easily want to run hundreds of runs of a model. Is there some sort of batch processing utility where you can set this up, get it going at 6 o'clock at night, come back the next morning to have all this data ready for you, or do you have to?
So the single best person in this hemisphere to talk with about this is sitting at yonder table. His name is Winchell, and I don't think he's currently where I'm talking about him. Winchell, would you like to ask your question?
Oh, sure. So, in situations where we're running a model with a lot of different parameter experiments, right? You're running maybe 50, or you want to run 50 or 100 runs of the model. Is there some batch processing utility where you can set it up and let the whole thing run overnight? I mean, whether it's within any logic itself or something that some other person has scripted in one of those useful languages.
Winchell, do you want to rise? And I'll turn the microphone. As is the nature of things, the microphone turns eventually from the master to the student.
I think it's fairly easy, for if you want to run create any logic models for many different parameter sets, and can be easily done by exporting the model into standalone Java applications, and then you can basically send this Java applications to nodes of the clusters, and then you just really trigger the running command, and then the whole cluster would work for you quietly at night.
Yeah, that's good.
It's reassuring to me.
And can you further comment? I think you've taken a bit of a look at AnyLogic 8.
Right.
Can you comment a little bit on the mechanisms that they support for doing this sort of computation on machines outside of your own?
Well, I think in AnyLogic 8 they do provide the accessibilities for the cloud services, which allow you to. The ideally is allow you to kind of run your models on a cloud, just like one step you don't have to really rent a cloud and then just deploy your models. You do this probably with one click or a few seconds.
Okay, and does that allow you for like a parameter variation experiment?
Yeah.
Could you run, like yesterday, do you remember we were running 121 runs here?
Right.
And they ran out, and there were maybe 4 running at a time because I had 4 cores, so-called cores on my
Right,
computer,
right.
which can run in parallel. Does this allow something like that to run on many machines?
I think it should be.
Yeah.
But for different parameters, like for different parameter variation sets,
Yeah.
it probably depends on the case. Because some of the parameter variation experiments have dependencies on different parameter sets, but some of them may not. And some of them can be run in parallel, purely parallel fashion, because logically it supports to do so. But
Yeah.
some of them are just so. If you want to do kind of sampling or something.
Sure. So if you're doing some more sophisticated things,
Right.
but if they can be run in parallel, like
Yeah.
these can,
Yes.
it's just same model, different parameter assumptions each
Right.
of them have, independent of one another. So as we say in computer science, they're embarrassingly parallel.
Yes, right. Exactly.
In that case, they could be mapped to large numbers of machines.
Right.
You think? Yeah.
If
Does
that
it?
can easily scale it out.
And someone asked me yesterday, is it using Amazon Web Services for the cloud?
Well,
Or is that something you could set?
For this one, I don't know underlying what they're
Okay.
what they use. We'll probably provide you a choice for search for choosing a ideal
A provider.
get provided, or probably just
Okay.
really provide by themselves.
Okay.
I think it's really depends on their.
Right. Okay. So that's helpful. Windchill has done a tremendous amount with as you described, cluster-based computation, where it might not be quite as embarrassingly parallel as this, but basically he'll take a given set of runs and he'll put them out, and then he'll harvest them on large clusters.
Right.
And that's something that he has trained a bunch of my other students to do. He as normal pioneered it, and then he trained some of my other students who now know how to do it as well. And the short answer is yes, you can put it out there and then harvest results, and that's what he's done for some of our papers, for
Yeah.
example. Jeff also.
Perhaps you should mention run fast.
Yeah, okay, that's good. I mentioned it only in passing yesterday without using the name. So, ladies and gentlemen, an important feature of parameter variation experiments that often motivates their use, and I'm grateful to Jeff for, as normally, being one step ahead of me with respect to these things, because there's basically three big uses of parameter variation experiments. We looked at two of them, but perhaps the most even more common use I neglected to emphasize, and I really should have, because it's at an equal level to the other two. So number one, we did look at these for running the model with the same value of parameters, just to see the effects of stochastics, right? Secondly, we looked at it when we do vary the parameters, how does it affect certain model outputs? Saw how to do that. I led you through the trickiness that traps a lot of people when they try to set up a parameter variation experiment, how to set it systematically. The third component, though, is perhaps even the most common use of parameter variation experiments, which has to do with the fact that when you run the model with a parameter variation experiment, it runs often significantly faster than with a traditional experiment. Why faster? Because it doesn't do any visualization and calculations for the visualization to display it. Some of my students, in a quest for a more performant simulation, in a desire to speed their model up, they have, in a fit of misconception, they have ripped out the visualizations from their model altogether. They have exacted them. They have extracted them. They have excised them from their simulation so that it runs without a visualization ever. And that's a grand mistake, in my view. It's a grand mistake because it represents a missed opportunity for communication. It forsakes the critical need within a team context particularly, and with stakeholders, of being able to show evidence of what's going on in the model. Visualizations are not to be underestimated in terms of their significance for communicating elements of understanding. And even for a dyed-in-the-wool modeler, someone at a level of a Windchill, someone who has great conceptual understanding for what's going on, a simulation visualization can offer a great deal of insight, because amongst other things, when it comes to debugging, when it comes to inspecting the results of the latest changes, you can also often clue into things that you would have had to pore through pages of numbers potentially to recognize. You can just see visually what's going on. So the visualization is much more than eye candy. And one of the things I've been doing here is trying to make sure, pursuant to the feedback in the pre-survey, trying to make sure that I feature successive visual elements of any logic. We'll have more of them coming. But trying to feature the visualization elements. And we'll be showing Windchill's model, Pertussis model. He'll have a little informal presentation of it, which he doesn't have to worry about, but he'll be showing without worrying about it. No need for a formal presentation. You could just show it, but which is really exquisite. But but basically the point is that makes the simulation run slower. It has to do actually a lot of calculations to show those visualizations. And when you set up a parameter variation experiment, it automatically says don't worry about all that. It uses a mechanism called run fast.
It's within.
Yeah, so it says, hey model, do your work. Instead of calling run, where the model will generate all sorts of data structures for visualization, we'll spend a lot of time drawing lines and changing people's color and having them do animation and all sorts of great stuff. Instead of doing that, which comes with run, it will call run fast. It will say, do your lean and mean kind of simulation, don't bother with all this visualization stuff. And so just by creating a parameter variation experiment, treating it as a one run thing, you run it, it runs main, that's all, you get that for free. And sometimes you could see a speed up of, you can have the running time of your model by doing that. You can also, very importantly, lower the memory footprint of your model, meaning it takes less memory. And if you're running your model at the same time, 4 different copies of it on your machine, or 8 different copies, that can actually be a really big thing, and it takes less memory. Along those lines, maybe I'll just note that if I were to run this model here, let's take this, and I am going to run a baseline thing here. Here's a baseline version of the model. Here we go. You'll notice it says memory down here. Do you see that? Now, I should also comment, this is all going to be buried in the retrospective. I'll have that. You'll notice that what is shown actually varies quite a bit. There's quite a bit of extra stuff that you can choose to see at the top and bottom. If you want to change that, I should note that if you go down to the experiment and you scroll down here, there's a thing that says, and I think it's under this window. Do you see window? It gives you a choice of what you want to see. For example, do I want to see a view menu, which lets me zoom in? Do I want to have that displayed by default? Do I want to report on the model performance, the events being processed per second? Do I want to set a number of frames per second associated with the model, or see it, how it's doing in terms of frames per second? Do I want to have it report on the experiment progress, etc.? These are things that I can actually choose that will add to what's shown here. Beyond that, ladies and gentlemen, there's a memory component here. You notice now we have events per second, EPS. Now, when I run the model, this is with 1,000 population, you'll notice it's using this memory here, okay? And if I were to go run it, over time the population will burgeon. We're seeing here only a fraction of the allocated memory, and sometimes it backtracks, which is an indication of garbage collection, I believe. It's actually capturing a bunch of garbage. If we were to run this out further, what we would end up seeing is that a lot more memory can be consumed with a large population, okay? And this can become a real issue. This can become red, in which case it basically is a sign it's memory constrained, okay? It's a sign it's running short on memory, okay? If you want to avoid that, one thing you can do is you can go up to the top. That will make your model run slower. You can go up and assign it more memory at the top of one of these, and that will actually potentially have it run faster, as long as you're not running too many of them on your same computer. Okay. Sometimes you need this for a large population. If I were to copy this population 1,000 baseline, and I were to make it population, let's try this, population 10,000. Now I have to engage in delicate frobbing here, so give me a second if I may. I'm going to make it 20,000. There we go. Okay. And I'll make it, okay, this is where it gets really hairy. Come on, don't crash on me, okay? 20,000 baseline, hey, come on, boom, okay. I'm gonna run it now, here we go. And I suspect we'll see a significant larger amount of memory being allocated. At the very first, yeah, here we go. So now it's taking over half, and there you go. The fox has shown its tail. Now it's become red, and this is a sign it's memory constrained. And often this is accompanied by taking a lot longer to do its job. Okay, this can trigger garbage collection here, I believe, this little thing. But really what you want to do is you want to actually allocate it more memory. This is a sign that it's just too constrained. It's like you've got a cockatoo in a cage that's 6 centimeters by 6 centimeters by 6 centimeters or something. Its beak is going to be sticking out. It's going to be in a bad situation. So you want to give it more memory, okay? And to do that, you can do so with this. I'll go up that amount of memory. Here we go. I'll go up that to let's say a gigabyte. I'll give it. Okay. Okay, and here we go. Boom. And now, having lent it a bigger amount of memory, it is going to, in fact, occupy a much smaller fraction of that memory. It won't be nearly as constrained here. Okay, so memory available, as dictated up here, can really make a difference for speeding up your simulations. Okay, yeah. Other questions I could, Anton, did you have another question? Okay. Windchill, so I should mention that I'd be remiss for not mentioning it. My group specializes, amongst other things, in tools for helping with any logic. Windchill is further responsible for this tool to export to R. He's also worked on similar tools to assist another student in creating tools to perform MCMC-based analysis with models, with simulation models. He's further and generally worked on the aspect-based programming to allow you to extend any logic with some extra features. For example, we have something which records information on what's going on that another student created, and that I think Windchill also helped a little bit with. Windchill also has these scripts for running code on clusters with any logic, and I think other tools that have come out of our lab may also be of interest. So if you do have interest, if you hear about anything we're doing and you're interested in tapping into it, we try to distribute it quite freely, and we'd be glad to share things like that. So if any of you have possible interest in putting on a cluster, want to hear what's involved, come talk with us. We put it on a set of teaching machines, so our department has a couple hundred machines for computer science students to use, and he has a script which basically goes through, check which machines are free at any time, and injects any logic simulations into those machines, and then they run on those machines at night, right?
Yeah, sort of called the poor man's cluster.
Poor man's cluster.
Or ad hoc cluster.
Well, yeah, it's although there are few poor men who have hundreds of PCs at their beck and call. I think there's also some mechanisms that you may someday work on to finish with the Boingo.
Yeah.
To sort of automatically.
Yeah, it's just further automation.
Yeah, further automation. So Windchill I think in the world he's like the furthest along for this. With the Boingo one, I asked him what it would take to finish the job. And basically, as far as I understand it, he's creating commercial level software that would be used worldwide by other people, and he would just have to spend 2 weeks creating it. And so we put that a bit on the back burner, having him do free commercial software development to finish a system that other people should be finishing. But he may end up doing that. But yeah, we have some tools in that area. Okay, great. So those were some comments here on the simulations. Okay, so this is on the slower side now. I guess I maybe took a bit too much memory there. Okay, so moving right along. I think those are. Oh yes, one other comment from yesterday. I want to reflect a little bit on this simulation. I'm putting together a teaching example which weaves in things, and today we're going to add more to it. Ladies and gentlemen, it's worth reflecting on the fact that here I had in mind certain level of research question with this. For example, questions involving the efficacy of certain interventions that might involve quit lines to help people stay quit, or provision of nicotine patches, and pharmacological support for individuals who are quit. Tobacco, anti-tobacco ads of the sort that I think you folks are world leaders in. I'm so impressed with the ads on your tobacco packages. In North America, and particularly in the States, it's just a horrible situation with the tobacco companies running roughshod. Tobacco companies hand out cases these days, cases for cigarettes, so you can put the carton in there, so you don't have to see the graphical labels on them. You can put the cigarettes in there, and then you don't have to be faced with this picture of a lung or what have you. It's horrible stuff. They also coupon online, targeting certain geographic areas that are subjects of anti-tobacco interventions or restrictive rules for minors purchase, etc. Anyway, the point is, I had in mind certain types of interventions. It's worth bearing in mind that when we look at this depiction of smoking, it's not to be assumed it's at this level. Perhaps these are the levels that are most discussed within the within tobacco policy discourse, never a current and former smoker. But for other purposes, with other research questions, we might go down a level of detail. For example, we're doing some work right now with Public Health Agency of Canada. They have a very, very strong interest in e-cigarette and cigarette interactions. And, it's a contentious area. To what degree are e-cigarettes predominantly a vehicle for quitting? To what degree are they a vehicle for, a gateway to smoking? To what degree are they just an alternative form of nicotine addiction that people can engage in when they can't smoke? To what degree are they an opportunistic kind of mechanism for use and are just interchangeable with smoking? These are questions which, to really probe them well and to ask, are they doing net harm, etc. We might want to engage in a more detailed representation of smoking, where it actually involves building up nicotine addiction levels, for example. We might be interested in some contexts about how the longer durations of exposures with e-cigarettes lead to differential effects compared to the short exposures for cigarettes. One of the interesting things that's come from our smartphone work, so we have this system which is now used worldwide for smartphone-based data collection, and in addition to having increasingly effective automatic ways of recognizing likely smoking behavior, one of the things we've done is we've also asked individuals to report when they're starting smoking, they're stopping smoking, and with e-cigarettes. And one of the things that really came out of that is that e-cigarette use exhibits patterns profoundly different than cigarettes. You think about cigarettes, the person takes out a cigarette and they light it and they smoke it, and depending on weather conditions, wind, etc., it may take 1 minute or 2 minutes to burn versus 4 or what have you. But they smoke it and it's done, and often stomp it out and go back to their work. With e-cigarettes, there's nothing directly comparable. They'll have a tank, a cartridge, and they can go for hours just using e-cigarettes. And so there's not a defined time where I'm going to have a cigarette, I'm going to have an e-cigarette, and then you come back. You might go on for hours. And so one of the things our smartphone work revealed is that people sit there for hours, often, for example, playing video games, just taking hits off their e-cigarette, for hours at a time. And so the exposure patterns are rather different, and the impact on nicotine addiction is different. To capture something like that and reason about its impact on smoking and this ecosystem of cigarettes, ladies and gentlemen, you may be dealing with a level of articulation where something like this is just not detailed enough. You want to actually simulate dynamics of addiction. So we have a model which does that, and Winchell has normal been involved in helping the students around the lab, and I think that's one of the models he's helped out some with as well. So there, this might not be an adequate level, the best level of description. We might want to go down a level and simulate dynamics of nicotine addiction in stocks and flows, for example. So here, what we've shown here is at a level of endogeneity suitable for certain investigations and not for others. Okay? You okay with that? Okay, great. Great. So, I think I'll stop a retrospective. Are there any final questions on this? Okay, so I'm going to stop this retrospective. Here we go.